Imagine a weapon so terrifying, so fundamentally destructive, that its own creators were afraid to test it on their own soil. We are not talking about a standard nuclear bomb or a conventional intercontinental ballistic missile, but a machine designed to be a literal engine of the apocalypse. During the height of the Cold War, in an era where the United States and the Soviet Union were locked in a desperate race for technological supremacy, American engineers conceived of a project so ambitious and so inherently lethal that it remains, to this day, one of the most controversial chapters in military history. This was Project Pluto, the quest to build a nuclear-powered ramjet cruise missile known as SLAM, or the Supersonic Low Altitude Missile. Unlike any other weapons system before or since, Project Pluto wasn't just designed to carry nuclear warheads to a target. The missile itself was a flying reactor, a screaming herald of death that would leave a trail of radioactive poison in its wake long before it even reached its final destination. To understand the sheer madness of Project Pluto, we have to look back at the late 1950s, a time when the boundaries of physics were being pushed to their absolute limits and the fear of a Soviet first strike drove the Pentagon to consider ideas that today seem like something out of a dystopian nightmare. The core philosophy behind Project Pluto was simple yet devastatingly effective: build a missile that could fly indefinitely at supersonic speeds, staying below Soviet radar, and capable of striking multiple targets with precision. The heart of this beast was a nuclear ramjet engine, a technological marvel developed at the Lawrence Radiation Laboratory. The logic was that a nuclear reactor could provide an almost limitless source of heat, which would be used to expand the air rushing into the intake, creating massive thrust without the need for traditional chemical fuel. This would allow the missile to circle the globe for weeks, if necessary, waiting for the command to strike. But there was a catch that horrified even the most hardened military strategists. Because the reactor was unshielded to save weight, the air passing through the engine would become intensely radioactive. As the missile roared through the sky at Mach 3, just a few hundred feet above the ground, it would essentially be a flying Chernobyl, raining down a lethal plume of fission products on everything it passed over. The shockwave alone from its supersonic flight at such low altitudes was estimated to be powerful enough to level buildings and kill people on the ground, making the missile a weapon of mass destruction even without its payload of 16 hydrogen bombs. The engineering challenges of Project Pluto were as monumental as the moral ones. The reactor had to be small enough to fit inside a missile but powerful enough to generate 600 megawatts of heat. It had to withstand temperatures exceeding 2,500 degrees Fahrenheit, which meant that standard metals were useless. The solution was the use of tens of thousands of tiny ceramic fuel elements, specifically designed to survive the intense heat and the corrosive force of high-velocity air. To test this monstrous engine, the government built a massive, specialized facility in the Nevada desert known as Jackass Flats. This site featured miles of oil well casing and multi-million-dollar air compressors just to simulate the conditions of supersonic flight. When the Tory IIA reactor was finally brought to life in 1961, it marked the first time a nuclear ramjet had ever been successfully operated. The sound was a deafening roar that could be heard for miles, a mechanical scream that signaled the birth of the most dangerous engine ever built. Yet, even as the technical milestones were being met, the geopolitical landscape was shifting, and the very existence of Project Pluto began to raise questions that no one in Washington was truly prepared to answer. One of the most significant problems with the Supersonic Low Altitude Missile was the logic of the strike. If the United States actually deployed this weapon, where would they test it? It was too radioactive to fly over the continental U.S., and even testing it over the Pacific carried the risk of creating an international environmental disaster. Furthermore, there was the terrifying prospect of what would happen if the missile's guidance system failed. A nuclear-powered robot flying at 3 times the speed of sound, unable to be shot down and constantly spewing radiation, would be a nightmare that no one could wake up from. Military planners also began to realize that Project Pluto was essentially too much of a weapon. It was so provocative that it might actually force the Soviet Union into a preemptive strike just to prevent it from ever being launched. By the mid-1960s, the development of relatively stable and reliable ICBMs like the Minuteman and the Polaris submarine-launched missiles rendered the complex and dangerous Pluto redundant. These new missiles could reach their targets in 30 minutes without turning the entire atmosphere into a radioactive wasteland. In July 1964, Project Pluto was officially cancelled, having never taken its first flight. It had cost the American taxpayer hundreds of millions of dollars and produced a technology that was deemed too dangerous to ever be used. Today, the remnants of the Pluto project sit as silent monuments to an era of unbridled nuclear ambition. It represents a moment in history when humanity was so afraid of its enemies that it nearly built a machine that could destroy the world just by passing through the sky. When we look back at Project Pluto, we see more than just a failed experiment in aerospace engineering. We see a reflection of the cold, hard logic of the Cold War, where the pursuit of security led to the creation of the ultimate insecurity. It remains a haunting reminder that just because we have the power to build something, it doesn't mean we should. The flying crowbar never saw combat, and for that, every living soul on this planet should be eternally grateful. As we move further into an age of autonomous weapons and hypersonic technology, the lessons of Project Pluto and its screaming nuclear engine are more relevant now than ever before, warning us of the thin line between defensive genius and absolute madness.